Okay, this is question 9 on the energy packet. This one is also fairly simple, but basically what this is asking or telling us is that a 60 kg ball is thrown up an undisclosed height. We don't know height. And that is a terrible line. Yeah, I don't care. And the initial velocity is equal to 4.60 meters per second. And it's asking us what the change in GPE is. Oh, that's highest point. Cool. So this actually is a lot simpler. I actually solved this just now, and then I realized, wait, like you don't have to do all that. Um, when you're looking at the question, right, it says ignoring air resistance. That means it's going to be a what is it? Conservation of energy, which means the energy down here at E initial is going to be equal to the energy up here at E final. There's a whole, obviously, there's no work thing. I just explained that though. So it's just, believe me, trust me. All right, so it means energy final is going to equal energy initial. Um, at the bottom down here, right? If there's not going to be any gravity, right? This is H equals 0. This is the ground. There's no height, which means if you plug in 0 to mgh, you're not going to, it's going to cancel out. So the energy down here for energy initial is solely going to be kinetic, which is this. And then that, whoa, and that is going to be say equal to energy final. And up here, obviously, when it reaches the highest point, as it says in the question, it's not going to be moving. Velocity is going to be equal to 0. So when you plug in 0 to the, the same equation on that side, you're just going to get 0 and it's going to cancel out. So all you really have left is mgh. So what I did originally was I plugged in my numbers here and compared, but really you only have to care about this portion of the equation. And the reason for that is we're looking in the change in GPE, right? And we're comparing it from the initial to the final. Because there is quite literally none down here to begin with anyways, we only really need to solve how much energy is up here at the top to give us our answer. And again, since it's conservation of energy and whatever down here is equal to whatever's up here, and they don't give us H, we can't really solve for up here, but we don't really care because as long as we can solve for what's down here, it's equal to what's up here, and that's going to be our answer, right? So we just solve for this. This is 1/2 60 velocity is going to be 4.6 squared. On my packet, I got 634.8. That could be a little off. Maybe I typed it in wrong on my calculator, but that's what I got initially. This was like the first question I solved on the packet. Um, so maybe that's a little off, but it rounds up anyways to 635, which is the correct answer. And that should be pretty simple. I don't want to skip a step in my explanation, but essentially, right, we have this is just what's equal to over here. If we were to plug this in, it'd be 60 times 10 equals h, and that equals uh, 634.8, right? But we don't know height, so we can't really solve for whatever this is. I mean, we could solve for height now, but the question's not asking us that, right? It wants to know the change in gravitational potential energy. Again, since there is none of that down here, because again, h is equal to 0, going from 0 to 635 joules, like if we're looking at the change, that's just going to be 635. The fact that it says change in gravitational doesn't really mean anything. It's just going to end up being our final in this scenario. So the answer is going to be D.